like to begin today's session just by first dispelling this rumor. Oftentimes when we talk about blockchain technology, many people kind of intermix the two terms, blockchain and distributed ledgers. And so I just want to say here at the beginning that while every blockchain is a distributed ledger, not every distributed ledger is a blockchain. And so with that, we'll still use the nom du jour blockchain throughout most of today's discussion. But we'll also talk about commercial applications. Now, I never like to begin a discussion assuming that we are all on the same page. So today we'll spend a little time talking about blockchain and DLTs, because I like to never assume that we're all operating with the same basis of information. And so we'll do a bit of a review for some and hopefully new information for others. And then we'll spend some time really digging into these concepts of centralized versus decentralized. We'll have a chance to review some of the more renowned or popular blockchain as a service platforms from some of the enterprise resource providers and the large cloud platforms. And then we'll talk about smart contracts, tokens. And then I'll end the class inviting each of you to discuss a commercial application that you might be interested in and show you ways that you can do it in a more formalized setting. So first, let's just begin with this definition of blockchain. And we are intermingling the two, but there are distinct differences that we'll discuss later. But really what we're talking about is a specific type of database. And in the case of a blockchain, that information or new transactions are stored in data blocks that are chained together. And we chain them together using encryption, but we chain each block of data in chronological order. And so for that very reason, the most prevalent or most common use case, most common usage of blockchains and distributed ledgers are that of, say, transaction ledgers, whether these are financial or audit trails, computer systems. Now, Bitcoin is probably the most popular example of a decentralized blockchain or distributed ledger, as we're using those two terms interchangeably here for now, where all the users retain some level of control, provided that those users are nodes. Now, decentralized blockchains, because of their inherent nature of being copies of a ledger stored on multiple servers and nodes, validating or processing transactions, multiple geographic locations. Once a transaction is agreed or validated, recorded on those particular blockchains, on those particular ledgers, we call it irreversible, meaning that there's no way to undo the addition of that new data block or that new data entry. Some of the key features of blockchains and distributed ledgers is that there's always some type of validation by consensus. And what we mean by this is that new information added to those networks, to those ledgers, it is done so not by the permission of one, but usually by some type of a consensus between many being reached. Now, we can reach consensus through solving cryptographic algorithm, or we could reach consensus through voting. We could reach consensus through varying degrees of authority. But no matter what type of consensus mechanism we use, you will always know that you're working with a specific type of database that is a blockchain or distributed ledger, in that there's some type of chain grouping, some encryption between the data blocks or the data entries. And in most cases, in most applications of this technology, once entered data is immutable, meaning that we cannot go back and delete that entry. Now, because of the nature of this technology, when we are sending information to multiple servers, multiple geographic locations, we will need to do so. We will need to have that information distributed and replicated in almost near real time. And given all of these characteristics, we then have this concept of unforgeability for most blockchains. It is quite easy to look at the unique signatures of blockchain hash and figure out which ones are not in chronological order, and therefore it's quite easy to spot forgery. Now, given the chronological order, immutability, unforgeability, we then have traceability in the terms of an audit trail so that we could go back and look at every transaction that was ever recorded on that blockchain. And a key thing to note is there are multiple types of blockchains and distributed ledgers. Now, some of you will know this gentleman picture here, and you will say to yourself, I don't remember him ever saying this quote. I confess that Vitalik Buterin, pictured here, did not ever say this quote. You can't find this him, but I'm sure some of you are already Google searching or using your preferred search engine to find out who in history said this. Well, a man by the name of Joseph Stalin famously made this quote when talking about power and information. And so whether we are looking in a government context or in a commercial enterprise, the responsibility of those organizations, those entities, or those governments is really to ensure the veracity of data and the control of information. In the case of governments, to protect citizens and serve citizens. In the case of corporations, to protect shareholder interests and to produce a good or service. So you're going to ask me, well, Phil, what does Joseph Stalin and Vitalik Buterin, what does all this to do with blockchain technology? Well, going back a little bit in history, in the post-World War II era, there were significant investments in technology, and specifically around computing power and encryption. And many of those scientists who were funded by governments in the West and in the Eastern Bloc went on to become some of the pioneers in commercial applications that used encryption. One of those scientists would later have a son, and this son's name is Vitalik Buterin. Vitalik learned encryption, computer science, universities in the Eastern Bloc and in Canada. And then in 2017, he decided to take his knowledge of encryption and distributed ledgers to build the first version of the Ethereum blockchain, which we know today as the most ubiquitous example of blockchains using smart contracts. And I'll talk a bit about smart contracts in a few minutes. So it all comes together that originally, because of the mindset of world leaders, not necessarily trusting the information that they receive, and then when they do have valuable information, looking for ways to store it and distribute it in a secure fashion, that we now have this technology, several iterations and several versions, that we can use for commercial application. But when talking about a decentralized or a distributed system database, like a blockchain or distributed ledger, we need to have a very firm grasp of what centralized versus distributed actually means. And so, for example, most of the corporations, universities, and private enterprise governments use centralized siloed databases and servers to maintain their digital infrastructure. And in those systems, there is almost always few key central authorities who literally have the keys to the digital kingdom. Now, we give them titles like Chief Technical Officer, Chief Information Systems Officer, or Systems Admin. But these are the people who give you permissions to your email and the email servers. They service your desktops or laptops necessary, and then they provide you with the various software tools needed for your day-to-day job. Maintaining these systems is quite expensive. They're quite bloated, and they're highly corruptible. And typically we'll see these systems built along division lines or ministry lines or within a specific product, say at a financial firm. Whereas a distributed system enables real-time data sharing. no longer needing to always reconcile reports at the end of the day, the month, quarter. And they're built with redundancy because there are multiple servers, databases operating within these networks. But most importantly, in a distributed system, there is distributed authority, meaning that there's no single point of failure. And so companies spend literally billions of dollars per year on cybersecurity measures and other countermeasures to mitigate what we call external or insider threats. So one of the most famous cases to occur of this type of insider threat was a man by the name of Edward Snowden, working at the National Security Agency, United States, my home country. But he was not some, let's say, James Bond type, but he was really a systems administrator who had central authority over important government databases. And he decided, for various reasons, to release that information to the public. And so whenever I speak with corporate executives or government ministers, I always tell them, take care of your systems administrators and your IT professionals. They are the most important people in an enterprise that depends upon centralized systems. So some of the advantages of centralized systems are that they are highly customizable. We can create centralized database or centralized server to perform almost any function and have very high throughput or processing power while doing so. And they're relatively environmentally friendly. And we could use a centralized server, though, to run a decentralized blockchain. Now, some of the disadvantages of centralized systems is that they don't necessarily always have a lot of computing power protecting the network and the connections between the various centralized components. And most of the time, because this is private enterprise or government service, transactions on these systems are not generally publicly viewable unless it's after the fact in a verification type of process or some type of audit. And even then, the authenticity of the data is often very difficult to verify. Now, decentralized systems and networks, they're very highly secure because generally you have a lot of resources, computing resources. In the case of a Bitcoin, you have a lot of mining resources maintaining the ledger, meaning maintaining a copy, the records stored on that ledger. These are very difficult to attack. Not impossible, but significantly harder to attack than centralized systems. But given that they have lots of redundancy, it's difficult to bring all the nodes, all the servers down operating on a distributed system. And in the case of a cryptocurrency, literally it's open to the public. So anyone on a public, permissionless, decentralized system can use it for whatever purpose the network allows. Now, some of the disadvantages of, say, a public, permissionless, decentralized system is that they reveal a ton of information. In fact, most of the celebrities who maintain cryptocurrency wallets around the world, their wallet address is known, their wallet balance is known. Some of you very easily right now can find out exactly how much Elon Musk owns in cryptocurrency. But given the large amounts of computing power used to record transactions on these networks, to validate transactions either through mining or through some other consensus mechanism, public permissionless blockchains are not very environmentally friendly. And in fact, there's a significant cost to the electricity and required to maintain these networks. Now, previously, we were using blockchain versus distributed ledger as sort of one amalgamous nom du jour. But really, there are some very distinct differences. I'd be remiss if I didn't point those out. So a blockchain is a specific type of a distributed ledger. And on that, we validate and store information, typically in blocks. The most common use for blockchains to date have been cryptocurrencies. Now, cryptocurrencies were all the rage over the past, well, I would say more 7 to 6 years ago. And then we saw the peak of the cryptocurrency market occur twice, once in January of 2019, and then again last year in 2021, between the March and May timeframe. And so in each instance, Bitcoin and Ethereum created new highs in the market, and other cryptocurrencies followed along that general trend. Now, distributed ledgers, though, are a type of a database. And so you could have, and some corporations will argue that they use distributed ledgers in their what we call batching process of multiple servers and multiple databases over different geographies. However, where those servers lack encryption, there's a key difference with a distributed ledger that does use encryption and that does have validation by consensus, recording of records by consensus. So I would argue that people who are using centralized servers, many of them to maintain the same data, although they're in different locations, because there's still a central authority maintaining all of those databases, that it isn't really a true application of a distributed ledger. Whereas with the distributed ledger, there are multiple parties, no single point of failure, no single authority. And that is a key distinction with distributed ledgers. All distributed ledgers maintain a cryptographic audit trail. So I said at the beginning, just about, let's see, 20 minutes ago, before our technical difficulties with the video, that all blockchains are distributed ledgers, but not all distributed ledgers are blockchains. Now, you've heard me use this word nodes, and then you heard me say servers. And so nodes are servers that operate on distributed ledger networks or blockchain networks. But what's most important is how they share information. It is in real time amongst all the nodes on the network and not in sequential order. And given that we're not moving information in sequential order from node or server number 1 to server number 4, this means we are less likely, impossible, but less likely to experience things in the cybersecurity world like man-in-the-middle attacks or attacks that would take a server offline and then prevent the entire network from operating. So for example, with these 7 nodes, if we were using a consensus mechanism of simple voting, or what we might call staking in the crypto world, for today's conversation, we'll call it voting. As long as 4, the 7 nodes here are present, we can have a majority vote agreeing to add a new record, new data, or new block of information to this particular network. So if for some reason node number 2 or node number 6 were offline, no issues. We still have a majority of quorum present. If for some reason in this particular information, only one server, one node was available, well, then we do not have enough presence, we do not have votes, assuming that each server only had one vote, to record a new transaction to the distributed network. So a node on a blockchain is essentially a program running on a single computer or a single server that allows you to connect to the rest of the blockchain or to the distributed ledger. And it connects with the other nodes and they send information back and forth. So in other words, there's no way to communicate with a blockchain or distributed ledger without communicating through a node. So if you have a smartphone, your laptop, MacBook, or your desktop, whenever you are sending information to blockchain or distributed network for storage, you are sending a request first to a node, a computer, server, running a program that controls access to the blockchain network. Now, in blockchain, and distributed ledgers, there are some key building blocks for success. And I start not in no particular order, but I save the best one for last. You must always have a cybersecurity person. Important to have a business sponsor or government sponsor who's a stakeholder willing to fund this type of a project. In the case of using smart contracts, you will also need a smart contract programmer. And then you need a blockchain expert who has the ability to understand exactly the use case or why you're using blockchain in your specific project and how that fits into the overall architecture and digital infrastructure of your organizations, your small businesses, or your corporations. But the most important thing you need when using a distributed ledger or a blockchain are partners in this endeavor. In fact, some will say that no one should ever blockchain alone. It's a little too wonky for me, but what I will say is that in order to have a true distributed ledger or blockchain technology implementation, you need peers. Peers who have the same read and write permissions as yourself and as the other participants within the network. So it doesn't matter if you're using a private permissioned ledger or a public permissionless ledger, you will still need peers. Now, in the case of a large multinational corporation or a large government ministry, oftentimes peers are different business units within the same larger organization, or different business units within the same larger organization, plus outside vendors, partners, regulators, and other stakeholders. So one of the coolest examples that I can think of in the local context with respect to blockchain technology and distributed ledgers was a venture launched by the stakeholder, in this case, Singapore Airlines, using the audit and implementation capabilities of KPMG with the computing resources and blockchain resources of Microsoft to transform the KrisFlyer loyalty reward program. So prior to 2018, KrisFlyer, whenever you flew using Singapore Airlines, you would just receive normal airline miles. And then in 2018, there was a proof of concept to see, can we tokenize, can we use KrisFlyer points in a way that creates a new economy or a new use case for these miles? And so to do so, we needed to turn the KrisFlyer reward system into very much a system that operated on a centralized network or a centralized series of computers and databases that were costly and difficult to reconcile, to a system whereby multiple parties could join that network and maintain an exact copy of the ledger balances of reward points. And so KrisFlyer created the KrisPay digital wallet. And in that KrisPay digital wallet, they then had a conversion event from just normal reward points to suddenly your reward points are now tokens. And most importantly, you can use those tokens to spend at participating merchants. Now, in the case of context, everyone would say, well, why is that needed? Why do we need a uniform token for spending across various merchants who happen to be some type of partner with KrisFlyer and Singapore Airlines? But if we broaden that perspective and we say, okay, how do we maintain the value without currency effects of KrisFlyer points such that they are valuable to our members and our participating merchants, irrespective of geography, then we start to understand why we would need a verifiable and distributed network that multiple peers have access to the exact same ledger. And if we read the last sentence in this brief announcement, implementing blockchain technology or distributed ledger for KrisPay tokens allowed Singapore Airlines to, one, create new partners, and two, reconcile payments. No, what they didn't write here was faster than the old manual process using centralized computers and end-of-day reconciliations, end-of-month reconciliations, and then auditing all of them. In this particular implementation, you have your auditor, your tech provider, and the business sponsor all operating using the same set of information in the same network. So blockchain as a service then grew out of this recognition that not everyone will have the budget necessary to hire a blockchain implementation team internally. Some estimate, and this depends on which management consultants you speak to, that looking at the exact same project and trying to look at the resource requirement for centralized implementation versus the distributed ledger implementation, sometimes the cost could be as high as 9 times different. And so if that's the case, most stakeholders, most business managers, most government ministers would only fund a distributed ledger implementation in the case that you need absolute security around the data and information. And so blockchain as a service was designed to help reduce some of the costs of using this technology by not needing to maintain your own nodes operating on a blockchain network, and to provide some level of technical assistance for those organizations wanting to use this technology who lack, say, in-house expertise. And so these managed platforms are provided by some of the largest, what we call enterprise resource providers, Oracle, Barracuda, and others, and some of the large cloud platforms like Microsoft, Google, and AWS. So just give you a brief highlight of all of them. So on the Azure blockchain workbench, Microsoft has a suite of services and capabilities that literally allow people with some technical ability to kind of drag and drop and create blockchain implementations. And so they provide you with the cloud-based servers, the access to the nodes to begin prototyping and testing your applications, where you can literally transform your business logic into coding logic for the use on distributed ledgers or with smart contracts. And so if we were looking at an enterprise, this is taken from Microsoft's Azure Workbench. We were looking at an enterprise and we started from our left to our right on this screen. We will see that there are multiple, say, interactions, multiple points of entry to this particular network. So we have this application, we have an Android app, smartphone applications, an Internet of Things device, IoT device, probably tracking a truck moving in a logistics supply chain or ship or document courier. And then that's sending information, in this particular case, to not only a centralized database, but also in the bottom right corner of your screen to what we call a distributed ledger watcher. That distributed ledger in this particular information isn't necessarily recording everything that occurs on the network, but is looking for specific events. And when those events occur, it makes a record that it then distributes and replicates with all the other participants using this particular distributed ledger. Now, there's also some financial information moving across this particular network, and that's then routed through both the Ethereum blockchains, Quorum blockchain, and then we can see on the far right that to do so, we are using nodes on the Ethereum network, and we are using the Azure blockchain as a service nodes that operate a version of the Quorum blockchain. And so all these pictures and all this diagram, what it's essentially trying to illustrate here is that information received, what we call the front end from users on smart apps, apps on smartphones and IoT devices, somehow ends up as a record stored on a blockchain, a distributed ledger, or a centralized database. Now, Oracle, one of the large enterprise resource system providers in the world, they offer a pre-assembled platform that will allow you to use blockchain and distributed ledgers as a service and combine that with other technologies like machine learning. And so Oracle, one of their foundational distributed ledger technologies is what we call Hyperledger Fabric. And Hyperledger Fabric was developed by the Linux Foundation in conjunction with IBM, Microsoft, and others as a distributed ledger that competes with, in some instances, or works alongside others, other blockchains. Now, Amazon and AWS, we won't leave them out. They also have a managed service creating, maintaining blockchain networks, nodes that connect to these public networks, or creating versions of your own private networks. And it's as simple as having your current developer operations person within your entity, enterprise, use your AWS account to unlock the managed blockchain service where you can then pick and choose different foundational blockchains. Now, 3 years ago, there were only roughly 5 blockchains offered on most of these ERP or cloud-based resources. Now, multiple. I would be highly surprised if you can't find the blockchain you're looking for on these particular cloud providers. IBM, the old consulting firm that's still going, gave us our original mainframe computers in the 1950s, but they also offer managed solutions, again, using Hyperledger Fabric and the consultants necessary to help you bring to life a distributed ledger themed project, whether you were a small business, medium enterprise, or government entity. So when we talk about commercial applications, talk about enterprise blockchains, we generally then have some need, either commercial or regulatory requirement, or simply just best business practice of why we might want to limit who we share the data with. In other words, we wouldn't make all the data public. For many years, I worked at 2 very large global banks. We wouldn't want to make all of our internal valuations or marks on assets public in real time always. And so therefore, a public permissionless blockchain like Bitcoin or Ethereum, the public version, wouldn't necessarily be good blockchains to use for business transactions in a large global bank. Or think about central banks that are experimenting with blockchain technology. It might provide more volatility to asset prices in the market if we saw all the internal workings of central banks on a public permissionless blockchain distributed ledger. So therefore, most enterprise blockchains, most commercial blockchains, are what we would call private permissioned ledgers or private permission blockchain networks, that we are excluding someone from accessing or seeing the data and information. Now, we might want to share that information internally amongst different business divisions, or between companies and their regulators, or between companies, their regulators, their vendors, and other suppliers. And we might want them to all use the same source of truth, the same data set, without needing multiple reconciliations of the same data or different formats. And so what enterprise blockchains allow us to do is all agree to a data scheme and a data format, but most importantly, a way to distribute and replicate that information across all the peers in near real time. And depending upon the throughput or the data transmission requirement, these implementations can be quite scalable. Now, there are types of enterprise blockchains, and one of them is what I've mentioned in the previous slide, our private permission ledger, meaning that a group or someone has decided to restrict access to the information on the network and the network itself from public view or from wide dissemination. But we also have consortium type of blockchains where companies join not only as just mere passive participants, but they are all foundational in the creation of the rules which govern this network. And therefore, we call this a consortium blockchain because it differs from just a private blockchain in that there's generally a very lengthy and detailed negotiation that occurs before the network comes together, as opposed to one or two parties agreeing to just create a network and then inviting others to join. Now, within consortium blockchains, we have something called federated blockchains, not listed here. But the only difference between a federated and a consortium blockchain is that a federated blockchain has some regulator or some oversight participant operating on the network who sees all of the information on the network in real time. Now, there are many organizations who are developing enterprise blockchain and distributed ledger solutions. One of them, a group of former banking executives led by one of the business heads at JP Morgan, created R3. Hyperledger also has enterprise functionality. And then there's Enterprise Ethereum, which is a version of the public blockchain, but only used for enterprise usage. And so depending upon the implementation, there's not always a hash created on the public blockchain whenever someone is using Enterprise Ethereum. And one of the most interesting cases of Enterprise Ethereum usage here in Singapore was a project by the name of Project Ubin, which was between the MAS and many banks and auditors here, trying to solve the problem of settling Singapore dollar transactions amongst all the banks and the MAS here at 5 p.m. every day. In pre-blockchain, that process could take 13 hours. After the first few versions, Project Ubin, that time was reduced to 22 minutes. Paxos is another company working on enterprise blockchain solutions for financial services. And then you have a company like Digital Asset Holdings that looks at the full gambit of economic sectors, from finance to commercial leisure to cryptocurrency assets. They're looking at enterprise blockchains from multiple uses. Now, earlier you heard me mention this term smart contracts. And so let me just tell you again that smart contracts is another nom du jour, because we're not really talking about legally binding contracts. And the code is only as smart as the developers or teams of developers that create it. So smart contracts is a term of art. But a smart contract inevitably will contain the terms and conditions of an agreement between peers. So each time we buy a new smartphone, whether it's an iPhone or Android, we go through, we set our phone up, and there's always a page that asks us to agree to the terms and conditions. Most of us don't bother reading all of those hundreds of lines within the document. However, the minute we click and agree, we have bound ourselves to that agreement. In the blockchain context, in digital context with smart contracts, we can use smart contracts to create multiple events or scenarios, or to run processes, or to help automate existing processes. But we can only do so if those people who are interacting with the smart contract have agreed to the terms and conditions contained within that smart contract. So when we talk about smart contracts, what we're talking about are digital applications or programmed agents. And those agents are created and defined by the coding logic, and therefore their actions are governed by that same coding logic. And typically we can send and receive information. In the case of a cryptocurrency, we're sending and receiving coins. Execution within a smart contract is still done on the blockchain via consensus. Now, we can use smart contracts as an extension or to help create some versions of digital cash. But we can also use smart contracts for insurance policy. Now, I don't recommend anyone in Singapore create their own casino or lottery. Is it technically possible to do so in a smart contract? Absolutely. Is it permissible? Absolutely not. So please do not go out creating your own casinos and lotteries using smart contracts. But we could also use smart contracts that have coding logic in them that are designed to execute according to certain events that are observable from either IoT devices or internet-enabled news reporting. And so if this is the case, then we can think of a smart contract as a programmed autonomous agent, but it's only programmed to do what its coding logic will allow at inception. It is important to note that while smart contracts published to public, permissionless distributed ledgers or blockchains are highly transparent, they're resilient, are always available as long as there are nodes operating on network. Once deployed, once published, we cannot alter those smart contracts in any way. There's no way to patch. There's no delete button. There's no backspace. So once published, it exists forever, as long as the network exists. Now, in the case of Ethereum, which, as I mentioned in the beginning of this course, is the most ubiquitous blockchain that uses smart contracts, there are online web-based tools that will allow us to create a smart contract. And so remix, the web-based tool allows us to choose a version of Solidity, the coding language in which Ethereum smart contracts are created, and allow us to compile that code and then publish it using either virtual machines, or we can connect to other nodes and other transaction providers that we have access to. Now, you've heard me talk a lot about tokens and cryptocurrencies. And so one of the most, well, if not the most ubiquitous token in the world is the Erc20 token. And now Erc20 token, ERC stands for Ethereum Request for Comment Proposal 20. There are several different versions of tokens on the Ethereum blockchain before there was a stable uniform standard created that all participants were willing to take forward and use as a base. But essentially what ERC20 standards allow us to do is create tokens that are uniform size and have some key characteristics that are unique. And so we sell tokens by interacting with smart contracts. Now, some of you will say, Phil, I've never interacted with a smart contract. And I will say that you are aware of. And here's why. Most people will use blockchain technology and never code a smart contract, never directly connect to a server node, but they will use a web browser or a mobile browser or some other IoT-enabled device that is communicating with a blockchain network. And so a lot of commercial applications using blockchain technology today do so in a very passive format. So if you don't ever want to learn how to code, but you still want to use blockchain technology, yes, it is possible. Tokens can represent a diverse range of assets. In the case of Ethereum, we use the Ethereum blockchain. If we were using a homegrown Singapore blockchain called Zilliqa, then we would be using Zilliqa tokens. Now, tokens have mandatory rules. Whenever we launch a smart contract to create a token, mint a token as we give the command, there must be a token supply. And thankfully, there are 18 digits to the right of the decimal place and another 18 or so to the left. You can create as many tokens as you want in most instances. But these are the functions and mandatory rules that we must have. And then a few optional rules will be things that in a centralized world would cause significant data breaks and a significant amount of time using to reconcile transactions or entries. Token names, for example, name and symbol, decimal place, it's all optional. Why? Because the most important thing, or the most important piece of information, is the transaction hash, or the blockchain hash, the cryptographic hash, which is the unique identifier for that block of information or entry of information on our network. So in other words, if everyone on this call, and I believe there are over 400 of us, if we were all entries on a distributed ledger, we could change our names to wherever we wanted. We could change our symbols. We could change all the unique identifying characteristics that we now hold valuable in primarily a centralized ID world, and the only thing that would matter is our cryptographic hash. That is the only thing that would truly separate us apart. So if we had to answer the question, who are you? It's sad to say, but maybe we'd have to say I'm 0x58237YB32, something like that. Now, non-fungible tokens. When we talked about ERC20 tokens, each ERC20 token is fungible, meaning that if it's issued from the same smart contract, you can exchange each token like for like. Now, a non-fungible token takes the cryptographic hash a step further, and each token then created has its own cryptographic hash. Now, the difference is in this concept of fungible versus non-fungible, you can find in your wallet, actually. If you were to remove, say, a Singapore dollar bill versus a Singapore coin, you'll notice that on every Singapore coin, you can exchange them like for like because they're all worth the exact same amount and there are no unique serial numbers on them. However, if you were to go to the store and present the clerk with, let's say, 5 $50 bills that all had the exact same serial number on them, well, you're probably in trouble because guaranteed 4 of them are fake. Only 1 of them is real. And so therefore, the Singapore dollar bill with its serialized numbers could be argued is a non-fungible asset. So likewise, in the digital world, a non-fungible token will have its own unique cryptographic hash. Therefore, it will lack equivalency. There's no duplicating or replicating that specific token. And if this is the case, we can now use that token to represent things like art, or personal identification, or loyalty membership, back to our KrisFlyer example, or even a passport number. Now, I'm not a graphical artist, hence what you see on the screen is probably not the right ratios and things like that. But the thing that joins these two gentlemen, this photo in the middle, is that the artist on the left created digital art called 5,000 Days in Human Life. And the fan on the right purchased this in an auction in Christie's 2021, and he spent Singapore dollar 93 million. Now, I'm not a fan of digital art to the point where I would spend $93 million. However, what blockchain technology enabled was this transaction to occur without the gentleman on the right knowing the gentleman on the left, and while maintaining the integrity of the asset. There's only one of them. So then if we can use a non-fungible token to represent a $93 million piece of digital art, in future commercial applications, we can use non-fungible tokens to represent real estate or fractional ownership of real estate, financial assets, or we can pre-purchase items that we want produced in the supply chain. Or we can use a non-fungible token to represent our citizenship, our membership. Now, another cool aspect of smart contracts is that we can connect smart contracts, we can connect distributed ledgers to a website or to a mobile app or an IoT device, and we can create what we call decentralized applications, or the trade name dApps. Now, these applications, they run on blockchains, they use blockchains, but they also involve other technologies. And so it is at this point, it is imperative I remind you that blockchain does not exist within a vacuum. To unlock the full potentials of distributed networks and blockchains, we must always do so with using other technologies. Now, we can enable a decentralized application to have multiple points of authority. And so some of the examples actually originally came from defense applications. If we look at websites like Tor or BitTorrent, Axie Infinity was a very popular game, which was a version of a decentralized application running on the Ethereum blockchain. But because it was so popular and because there was so much value in that network, it was targeted by official state hackers from entities that have been banned. And even though they couldn't corrupt the blockchain layer of the network, they did find a vulnerability in some of the middleware operating within that overall system. And they were still able to steal about 400 million US dollars. Now, one of the coolest, least talked about kind of blockchain and distributed ledger related technologies are decentralized autonomous organizations, or DAOs. Now, DAOs are effectively smart contracts that we have given code and logic that automate decisions, automate events. And so we could literally program a DAO and fund it to maintain things like a disaster recovery insurance policy, or to maintain an endowment or a charity. We could use a DAO to even create an offshore decentralized corporation. But again, this is just a technical capability. We still must always keep in view what is permissible and allowed by local jurisdiction law. So we now live in a world where no one takes anyone's word for anything. In fact, I was traveling around the US, and fortunately, when I landed at Customs and Immigration a few months ago, they said, "Oh, can you prove you're vaccinated?" And I thought, yes, I can. I took out my SingPass app, and I went to my documents and personal section, and I found my vaccination card, all within the matter of 2 or 3 minutes. But as I looked around to see how other people were proving their vaccination status, you literally see people holding up pieces of paper, and the immigration customs officer looking at it through like a magnifying glass or holding it up to the light, because what they were looking for is this paper legitimate? Is it real? Does it tie back to an approving authority? Well, with health certs, we don't have that need for verification here, because every record is verified and certified by the government of Singapore using blockchain technology to ensure that there are no fakes, there are no illegal duplication, and that each health cert that's issued has its own unique cryptographic hash in the header of the document. So here's a classic example of using blockchain technology for commercial application in a passive way, such that the user does not care that they're using blockchain technology. The only thing that the user cares about is I can prove and vaccinate. And so when we think about commercial applications, we must always think about the use case. What problem for the user, the corporation, or the government entity are we seeking to solve? And how do the unique characteristics of blockchain and distributed ledgers solve that problem? Now, I'm sure you will have a lot more questions, and some of you will want to explore this in greater detail. So starting very early next year through ACE, the Advanced Computing School within NUS's School of Computing for Executives, we will have a 6-week course where we literally walk you through the steps of creating a commercial application that uses a blockchain or distributed ledger. And it's asynchronous. You won't have to listen to me in real time, but I am available. And of course, aides are available to answer your questions. You'll have an opportunity to literally walk through this technology, build a use case, validate that use case, compare it with peers throughout Singapore and the wider region. That platform is offered in partnership with 2U, the online education company. Now, some of you will want to literally code and make smart contracts. So you can do that with myself and my colleague, Reshma Balarama. Our next class, or one of the classes that you can sign up for next, very early next year, And so my colleague Mei Ho will post the links to these particular classes in our chat. I recommend that you take advantage of them because in this course, we literally open up Remix, that web-based portal that I showed you, and we walk you through line by line how to create smart contracts for various industries. You can also follow ACE, my fellows, and the professors of ACE throughout various social media forums. There are a series of webinars and courses that are available now. We also from time to time publish articles. And then there are a few events coming up as well. So as always, in everything we do, we would love to hear your feedback. Our friends and partners at Smart Nation have provided this QR code and this link for you. Please let me know how I'm doing and let us know how we can better provide content and insight for you. Now, the title of this class was Blockchain Commercial Applications. And so what I wanted to walk you through here was not everything that was going on in the market, but first, what we have available in terms of existing applications, the foundation of various technologies, whether it's blockchain or distributed ledger. When we talk about smart contracts, it's important to understand that we're simply talking about programmed agents that operate on a blockchain network or distributed ledger network. And then lastly, it all comes together in that we are using this technology to solve enterprise problems, government problems, or real world problems for individuals, such that if someone walks up to you and they want to know, who are you? One day it's as simple as flashing a QR code that connects to a cryptographic hash rather, and then they'll know exactly who you are. So all of your particulars are there. Or if you're standing in line like me and you need to prove your vaccination status, blockchain technology has enabled you to do so in a trusted way. Now, I'll stop sharing here and answer questions that were posted to the chat during this talk. And so I will scroll to see if I see any questions here. If not, please feel free to post your questions in the chat now. Okay. I see a question here, and hopefully you won't mind me saying your name. Hopefully I didn't mispronounce it. J.E. Gao, you asked how mature blockchain technology currently, and how far away are we from realizing Web3 concepts? Well, I would say that while we are certainly about 7 years into the most recent kind of blockchain theme, especially if you look at the investment and the protocol, the foundational blockchains that now exist, of which there are hundreds, we are still in very early days. And the reason for that is because so much money and so many resources in terms of computing knowledge went towards just creating blockchain, creating the encryption, creating the consensus mechanism, creating the throughput. But we've not yet seen, say, dramatic implementation of applications that use the technology. In Canada, there's a company called Dapper Labs. Now, some of you may have heard of this digital art called CryptoKitties a few years ago. When CryptoKitties first debuted, they crashed the Ethereum network. There was so much traffic because so many people wanted to buy CryptoKitties, these little things that look like kittens, but they were digital assets. And at the time, they weren't worth much, but now some of them are worth hundreds of thousands of dollars. Well, because they found during actual implementation that you slow down the Ethereum network considerably when you're using blocks of data that have very high memory requirements, Dapper Labs needed to create their own new blockchain. And so they were able to do so. And in doing so and experimenting and iterating over a 2 to 3 year period, now they are some of the foundational NFT providers in the world. And they partner with the likes of the NBA to produce video game clips that are effectively non-fungible tokens. Now, Web3 as a concept, I think we're still very early days, especially when we talk about things that impact our day-to-day lives, whether that's government service or education services for ourselves or our children, wider family. So I think to move towards a true Web3 kind of hybrid world, we still need more investment, both in terms of capital and in human resource. Mr. Ong asked about ETH's POS implementation, point of sale implementation for commercial applications. And he's pointing out that there's this tension between kind of centralized and decentralized applications and infrastructure. Completely true. So I like to tell people, ask people this question. If you're standing in line at your favorite kopitiam or your Starbucks and you order flat white, a long black, any type of latte or cappuccino, right now in the existing world, if you tap your credit card, time it. I guarantee you that entire process, after you've waited in line, you order, you know exactly what you want, and you pay, we're talking about 5 seconds or less. In the blockchain world right now, because throughput on public permissionless blockchains is not yet sufficiently high enough, that transaction could take you anywhere between 30 seconds to a day or so. And so can we have merchants waiting 30 seconds or a day to confirm a transaction? I argue no. And so even though I'm very much a proponent of blockchain technology and distributed ledgers, I think the more accurate implementation for normal everyday commerce is probably a distributed ledger, but not on a network that everyone in the public uses at the exact same time. So you might need to have smaller networks just until we have true throughput of blockchain transactions or distributed ledger transactions that can exceed that of centralized servers and systems that the credit card companies use. So right now, all the implementations of MasterCard, Visa, American Express, they're all using centralized servers with very high throughput, and they're in some instances experimenting with distributed ledger technology working with startups. And so we have another question from Mr. Ong. He's asking us some very good questions here. What would we consider a successful evaluation of a smart contract, say for large scale commercial applications? Well, what we found is that part of the reason why there seems to be an emerging big 3 or 4 in the blockchain space is not necessarily because of the characteristics of the blockchain, but because of the computing power that's developing and iterating and building open source applications or code that's available for others to use. And so while personally, I like a few other blockchains that are less well known, those networks, those developing teams lack resources in that they don't have peers who are iterating with them, who have joined them. And so blockchains like Ethereum and Solana, Hyperledger, R3 with Corda, they have significant resources behind them, whether it is private enterprise or government entities who are using this code base and developing it further. Whereas some of the less well-known blockchains lack that kind of support. So when we talk about commercial applications, remember a commercial application is going to have one important thing, and that's a stakeholder. So if you're pitching a project to a stakeholder to say, we should use XYZ blockchain, one of the first questions they'll ask you is, what's my risk? And when you have that discussion of risk, it's not just financial and reputational risk, it's also, will this blockchain exist in 3 or 4 years? Is there a significant community behind it? Now, we saw this in the coding space when we all moved, or not all, but as companies moved from having very customized, highly individual web presence to then using frameworks like Angular and React, which brought some standardization that still allowed for customization. But prior to that, every company had to have their own bespoke framework and website. No different to what's going on in the blockchain space. A lot of private companies thought that they needed to create their own blockchain first. But if you blockchain alone, then you need significant resources. And I'm talking about hundreds of millions, if not billions of dollars to support that type of an ecosystem. Here's an interesting question from Lewis Coe. He asks, how do we regulate, provide governance or formal judicial controls for digital assets and take into account privacy and security? And so Lewis, this is actually something that we touch upon in our asynchronous course on commercial applications using blockchain. We have a full module that discusses this, but I'll give you a preview. One of the things that we need besides regulation is actual settled case law. And what I mean is that we need two parties of opposing sides to walk into recognized courts and have a dispute that involves blockchain technology, distributed ledger technology, such that there is a decision that has been appealed, and that appeal works its way up to the highest courts of the land. And there we have a decision and it becomes a precedent and settled case law. What we lack in many jurisdictions, whether we're talking about Singapore, the UK, the US, all throughout the Middle East, is that we've not had disputed blockchain court cases that were settled. And so in addition to regulations, so in Singapore, we have the Payment Services Act that regulates a company's abilities to use digital assets for payment purposes. Now, outside of a payment purpose, if you were to create your own digital asset, right now, there's no regulator who's shaping the contours of what's permissible and not permissible. And so what I like to tell people is, don't just think about what the technology can do, so the potential of the technology, but think about what is ethical or unethical to do. Think about what is permissible or unpermissible in real life, and then apply at least that standard to the digital space. So for example, while we can create, and this is one of the saddest implementations of blockchain that I've ever heard of, and it breaks my heart. While we can create digital record, create digital identities to help people who lack government issued IDs, there are criminal organizations who will create digital IDs of individuals and forever trap them in criminal activity. And so it's the same technology, but the use case and the ethics behind it were differentiated and matter most. The biggest, thank you, YG Duo. What's the biggest bottleneck in commercial adoption? Quite honestly, I believe that the biggest adoption to commercial adoption the biggest obstacle rather has been people like me. When I joined the blockchain world after leaving my career in banking, I spent so much time thinking, tinkering, and preparing to build like a blockchain. And sometimes when you are inspired by technology, you forget that it needs to have a purpose. And so we need to understand we can use this technology to solve real world problems. In our course, the Making Smart Contracts course, I'll tell you the coolest project that one of our students ever created. She had no technical experience. She was a teacher here in Singapore. And we assigned her group, okay, go off, create a blockchain token, come back and tell us what your token, the use case, what is it used for, and why. And she began her presentation by framing a problem. It was almost like a classic startup pitch. She said, here's the problem. I have students who do not eat dinner because where they live in the heartland, one or two of the parents or maybe both parents aren't home in the evening for various reasons. And so if I had a wallet solution and this custom token that could be used at restaurants, hardware stalls around the island, then my students would have a way to eat dinner in the evening. I would have a way of verifying that they purchased food. And more importantly, I wouldn't need to worry that the money that I gave them was used for some other purpose than what it was intended for. And at that moment in the class, I was literally dumbfounded and floored because it was a problem that I had no visibility on, a problem that I could not see, and quite frankly, a problem that I didn't understand until she explained. So the biggest bottleneck for the commercial applications adoption of blockchain is a failure of imagination and understanding the problem that we're solving. So if I want to use blockchains, for example, for global cross-border payments, well, you better have an understanding of politics and the sensitivities of various governments around their currencies around the world, such that when you're proposing that type of a project, you can mitigate those objections. Or if we want to create, say, real estate assets, tokenizing them using a blockchain, well, then we need to understand local sensitivities around foreign ownership of property and how we can mitigate or account for those type of risks such that it doesn't become something where people protest on the street and you lose a stable government over something that was unintended. And so the technology will allow us to do many things, but we need to focus on what problems we are solving and why. Checkable Fu has asked a question that he knows the answer to. He asked, will quantum computing eventually break blockchain immutability? Yes. So everything that we are doing right now to bring about widespread adoption of distributed ledgers and blockchain technology, this is not the end of the iteration. In fact, we are still at the very beginning, and we will need to iterate to create blockchains and distributed ledgers that move at the speed of quantum computing. Because right now, if, for example, a few small people in the world use quantum computing to attack distributed ledger or blockchain networks, then the speed of that computing power could overcome the speed with which the blockchains try and record transactions. Therefore, we can just theoretically dump massive amounts of irrelevant information in order to break up these networks. So there are people already experimenting with using quantum computing and blockchain technology. As an anonymous attendee asked the difference between Bitcoin and Ethereum. Well, the biggest difference right now, as of a few weeks ago, between Bitcoin and Ethereum is that Ethereum uses a different consensus mechanism now. Previously, they both used what we call proof of work, meaning that the nodes needed to solve a cryptographic algorithm in order to have permission to record a transaction or validate a transaction on the network. Now, in Ethereum, we are using what we call a proof of stake concept as the consensus mechanism, meaning that the nodes that own the most number of Ethereum will have greater precedent or priority in the queue of agreeing to record new transactions, and they will have greater priority in terms of the overall number of transactions they can. Oh, this is a cool question. How does a verifier link, this is another anonymous attendee, how does a verifier link an identity hash back to a person? It says, for instance, can two persons share an identity hash, or one person have two hashes? This is the perfect question because it uncovers the real use case for why you're doing this. And I would argue that in some instances, while what you're describing is theoretically possible, but think about it, if you do it, it will be known. So when we use blockchain technology, We don't, as I say, use it as a vacuum. We use it in conjunction with other technologies. And one of the coolest things that have happened is using blockchain to create unique personal identifications in conjunction with biometrics and your Face ID. So in the old days, pre-digitization, it was quite easy to fake certain countries' passports. Now, for example, if you were to go to China, when they scan your passport, China's been using blockchain technology in its immigration service for at least the past 7, if not 9 years. If they match your fingerprints with your unique likeness and your passport number to multiple entries on their internal blockchain, you are going in an interview room and you are probably going to be spending some time in prison for identity theft and using fake IDs. So this is one of the ways that we could take biometrics, one technology, face recognition, another technology, and combine that with a user interface and blockchain technology to create a unique identity for an individual. And this particular implementation is to protect the borders of a sovereign country. One attendee asked, would permission blockchains have more real-world applications than permissionless because of data privacy? Absolutely, 100% agree. In permissioned blockchains, what I think you will see quite soon become very prevalent is this use of federated blockchains, especially in things that could cause great heartache for countries or a civil unrest. So for example, part of the reason why R3 Corda came into existence was the security around asset ownership of US financial assets. In most, even in Singapore, this is the case, most financial services firms, when you, for example, if you buy a stock from a broker, that you don't physically own the stock. You own an entry into a ledger, a centralized ledger. Well, those centralized ledgers were maintained by companies called transfer agents. And transfer agents are the people who keep the official book and record of every company, their shareholders and their debt holders. So if I were a malicious actor and I wanted to gum up the works of the international financial system, I don't need to attack big banks. I can just attack the transfer agents who keep this information in centralized ledgers. Well, this became a risk that governments were aware of about 20 years ago. And so they started keeping multiple copies of the same ledger in different places, but there was no real-time updates. And so if this were ever tested because of a real world reason, we would have a huge reconciliation problem because one list might have assets as of a week ago, one list might have assets as of yesterday, one list might have assets as of somewhere in between there, but which one was true? And so then governments would have the thorny issue of solving that. So what blockchain technology in the case of a transfer agent is trying to do is provide multiple copies of the exact same record so there's one source of truth. But that can't be a public permissionless ledger. It has to be private and maintained by not only the transfer agents and some of the key financial organizations, but also key ministries or departments within government. Oh, this is a really cool question. Many blockchain ecosystems are backed by investors. So how decentralized are they, really? Mr. Daoud, I think that is a perfect question because what blockchain technology actually could enable, depending on how it's implemented, is greater control over data by the nodes. And if there are few nodes, then those few nodes have greater control or greater read and write capabilities than other people interacting with. And so this is where the ethics of the technology comes into play. And this is also why some blockchains are favored by large enterprise and governments versus others. I'll give you an example. There are certain networks where the founders will maintain a significant majority of the tokens or computing power that operates those networks. And in that case, Many will argue that is a centralized version of a decentralized application or process or network. Whereas there are several blockchains that are absolutely open source. Anyone can use them for any purpose. And therefore, those blockchains are generally favored by governments and larger enterprises. Now, I'm sorry that I couldn't get to all of your questions. There's still quite a few more here, but we are coming up on 1:30, and I must end this lunchtime discussion. I want to thank each of you for joining today. Thank you for everyone who asked a question.